because currently, as of now,
Yeah.
as participants, they do not have the permission to unmute themselves. So we have to allow it later on.
Yeah.
Okay, if we cross 50 participants, we won't be able to have permissions for this. So what we'll do is rely on text completely, and or else we'll call them on Discord or Google Meet if we have the time.
Sounds good. So should I start, or should we wait maybe a couple of more minutes? I see there are still coming some more attendees every minute.
Yeah, I
maybe
think
we should wait like 2-3 more minutes.
More. Yeah, you could just give a couple of minutes more, and we'll have more people join in.
I guess with a name like Aista in India, I should expect everybody being a little bit late.
Yeah, that was a great pun.
I never knew that actually before here on Monday, that Aista meant slow in Indian. And actually, it's kind of like what we are trying, because I mean, our slogan is the software developer's dream, right? And in a way, we want to like communicate our product such that, you know, people understands that if they're using our tools or Magic Cloud or using it, they can take it more slow in a way. So it actually perfectly makes sense for us that it means slow in Indian. So
awesome. It's good to know.
Yeah. $45. Yeah, to those just recently joining, I added a link to my LinkedIn profile and my email address, and to our website at the very top of the chat, so you can find it at the top. It probably says Thomas Hansen.
I'll pin that message. The message has been pinned, so it will be visible at all times. So no need to scroll.
Thank you, Divya. So should we start maybe? Shambhavi, what do you suggest?
Sure, let's go ahead.
Yeah. So my name is Thomas Hansen. I'm a native Norwegian living in Cyprus. I've been living 3 years in California. I'm a serial entrepreneur, and I am the CEO of Aista, which is a privately held small company based out of Cyprus. And in today's session, I'm going to demonstrate something we are very, very enthused about ourselves, which is 100% open source. There's a link at aista.com where you can download it. And I would like to encourage everyone to follow what I'm doing if they can, if they have already installed Magic. Then you can do that easily using your own machines. If not, then you can ask, at the very least, I know Sam Varghese has managed to successfully install this locally. He might be able to help you out if you're stuck, etc., etc. So let's have a look at today Magic Cloud. I'm going to share my screen here now and just verify that everybody can actually see my screen now, right? Sam, can you see my screen?
Yes, it's visible.
Yeah. So this is basically Magic Cloud. It is a software development platform with an edge. And that edge, of course, is automation, as in automation of the process of developing software. So let me first log in here. Of course, I'm on my local machine, so I have admin as password, as all good software developers typically do. And here you can see the dashboard. Now, obviously, in a 2-hour-long session, I cannot dive deep into every single aspect of this. I calculated I have roughly 5 minutes on each component in this dashboard. And of course, I want to also dive into Hyperlambda, the programming language that actually facilitates for this. But it will have to be not a very deep dive, but just a surface dive into the thing. So now here, when you log in, and yet again, you can install this locally on your own development machines in probably 5 minutes using Docker, assuming you can get Docker up running. If you can't get Docker up running, you can also download the entirety of the source. The system is built on .NET Core 6, version 6, and Angular in the front end. And it's a complete separated SPA, single page application with a backend entirely based upon JSON HTTP web APIs. So here you can see a couple of traits about this particular server I'm into now. Okay, we can see the default database is MySQL. I have 235 log items, 1 cache item. This is the version of the system I'm currently running, the backend version. Here you can see a number of slots, which we're going to be talking about a little bit later. A slot is basically like a function, but Hyperlambda being a very, very different programming language compared to everything you've previously seen, regardless of how many programming languages you know. It doesn't actually have functions, even though it technically is 100% pure functional programming language. So we refer to these functions as slots. Here you can see dynamic slot, number of HTTP endpoints this particular backend has, persisted tasks, etc., etc. And then, of course, there are some nice graphs here and stuff like that. So let's first go to item number 3 here, SQL Studio. SQL Studio is basically exactly what it sounds like. It is the ability to execute SQL. If I want to select all from, and I have autocomplete here, users, I can select users here now, and I can immediately extract the results, and I can even export it as CSV and stuff like that. And of course, it doesn't, stop with select statements. I can also do inserts or whatever. It's basically the equivalent of MySQL Workbench or Microsoft SQL Server Enterprise Management Studio, or PHP MyAdmin for those having used these systems. And of course, I can have multiple SQL result sets, and I can execute. If I select this part of my SQL, then it will only execute this part. If I select this part, it will only execute that part of my SQL. And one of the cool things about this is that if you're trying to teach yourself SQL, as in relational database management systems, then it actually allows you to persist snippets and save them on the server. So I've now saved that snippet. If I now refresh the page, obviously the SQL is gone, but I can reload this snippet, allowing me to easily play around with SQL. So it's a very nice tool to teach yourselves SQL if you are doing some sort of relational database management classes at university or things like that. However, let me show the primary feature of the system, which obviously is software development automation. So here I have a database called Sakila. It's an open source database published by Oracle that basically creates a MySQL database called Sakila. And it's a very well-known open source database. It's used for all sorts of things in regards to teaching yourself SQL and stuff like that. And you will find probably hundreds of tutorials online using this particular database as a foundation for teaching SQL constructs, such as inner joins or grouping or aggregate functions from SQL, etc., etc. Just to verify that I don't have it, and I actually do. So I guess I can do drop database Sakila first, and execute only this part, and then I can just delete it, and then I can execute this SQL. And of course, this is database definition language, allowing me to actually create a database using SQL. So you can see it creates a schema, then it creates a table, actor, then it creates another table, country, etc. Now, of course, if I do, if I refresh now, then it will refetch the server-side cache, retrieving meta data information about my database, allowing me to actually use this particular database and get syntax highlighting and autocomplete. If I want to do select all from actor A, inner join, film underscore actor FA, inner join film F on let's see, a dots, actor ID equals a dots, actor ID inner join film f on f dot film ID equals fa dot film ID where f dot title like a%. Let's a dot first name, a dot last name, f dot title. Error from actor A, inner join film actor FA, actor D, on. And there we go. And now you can see, obviously, it's basically executing two inner joins, retrieving through the many-to-many relationship table called film_actor, retrieving every single film and repeating every single actor for every single, or repeating every single film for every single actor that actually plays in this particular film. So it's basically a film database, and with the purpose of allowing people to play around with SQL, such as the thing I did here now. So I'm not sure how much I should dwell with the actual SQL, because yet again, there are 16 menu items in Magic, and we need to make it through all of them. The point is now, I do have a database here. I have a Sakila database, at which point I can go to the CRUDifier, and of course, this is the primary purpose of the system, that it automatically creates code. Now I can select this database, at which point Magic actually retrieves metadata for every single table, every single column, index, foreign keys, everything inside of this database, and automatically wires up a default web API for me. So here you can see I'm looking at the actor table. You can see all the columns in this particular table. Now, of course, it's centered around CRUD, implying create, read, and update and delete. And I can go through and configure on an individual CRUD verb level, whether or not I want the actor ID to be a part of only the read, update, delete invocation, etc., etc. And then further down, I can provide a primary URL, which becomes the module URL. Then I can provide a secondary URL, becoming the table URL and authorization requirements here. And I can even supply reCAPTCHA values for creating actors. Okay, let's do 0.5. reCAPTCHA, of course, is Google's CAPTCHA API, allowing us to prohibit bots from actually invoking our endpoints. And I can even publish signal R or socket, WebSocket messages upon invocations to create endpoints. Authorization value here implies rules, roles that the user needs to belong to in order to be able to actually get these messages as the WebSocket messages are published. And now, of course, when I click CRUDify all tables, 1 second later, the system has produced 3,457 lines of code. Now, according to conventional wisdom and research in the area, the average human software developer can produce between 325 lines of code and 750 lines of code per month. So Magic just now in 2 seconds produced 3,500 lines of code for us automatically. Now, of course, that comparison might be a little bit unjust, because obviously the type of code that Magic produces is extremely standardized type of code. It doesn't apply business logic. It doesn't create graph object endpoints. There are many, many things it doesn't do, but still, let's ignore that for the moment and look at what it actually does. If I now go to my HTTP endpoints and I filter on Sakila, every single one of these HTTP endpoints was actually automatically created for me as I click that button in 1 second. Now, if you look at the actor get endpoint that basically returns all actors in my database, you will see I can immediately now invoke it, and it retrieves all columns from this particular database. And even if I copy the full invocation URL, of course, this is an HTTP GET invocation, so I can actually use it as the foundation for a URL. I just paste into my browser. However, now I'm in incognito mode, implying I am not authenticated towards this particular Magic backend. Of course, I'm not going to get anything. Access denied. Why access denied? Because by default, the authorization requirements of the endpoints that Magic produces prohibits anonymous users from actually invoking your web API. And this is using JWT tokens. And for those not acquainted with JWT, let me post a link to you here in the group chat, which is https://jwt.io. And this is basically the de facto standard currently today for authenticating HTTP invocations between the client and the backend. And as you can see, I can parameterize my endpoints. Now it's only getting 2 records. And offset my invocation. Now it's getting from offset 5. I can order by, for instance, last name, and I can order both ascendingly or descendingly. Now it's offsetting 5 records, limiting to 2, ordering by last name, descendingly, so it will probably return 2 items outside of Faye and Angela here. Actually Wood, sorry, last name Wood and Witherspoon, because those are fairly large out in the alphabet. And of course I can filter if I want to. Actor first name like A%. Now it's getting only actors whose first name starts with the character A. So that is basically the CRUDifier and what it actually does for us 100% automatically. So let's look at the resulting code that the CRUDifier actually produces. And yet again, I want to emphasize this tool is in its entirety open source. You can download it, you can use it for creating proprietary code. You don't have to tell us about it either. It's permissive open source, as permissive as we can financially justify. So we are not selling licenses for this whatsoever. And I highly doubt we will ever do that. So let's have a look at the HyperIDE. HyperIDE here now, sorry, is basically a fully fledged IDE. Some examples of existing IDEs you probably know are Visual Studio Code, Visual Studio, PHP Storm, Rider, etc. And HyperIDE is basically an integrated IDE inside of Magic, specially tailored for editing the resulting code of the CRUDifier, right? And what is the resulting code of the CRUDifier? Well, here is my file system on my server. If we expand the modules folder, then we expand Sakila folder, then you will see all of these files were automatically generated as I click the CRUDify that particular database automatically for me. So let's have a look at the actor get endpoint here. For instance, maximize now the code editor. You will actually see the result of the CRUDifier. And this is Hyperlambda, which is a super high level programming language. Now, typically, when you are taught about high level programming languages and low level programming languages by your professors at university, they will typically refer to something such as C being low level, assembly being even more low level, and then stuff such as C# and Java being somewhere in the middle, and PHP and Python maybe high level. From Hyperlambda's point of view, even Python is assembly code. So Hyperlambda is the arguably by far most high-level programming language, I would argue, that possibly exists. And the reasons for that is because there are no constructs in Hyperlambda such as streams. There are no constructs such as a byte. You can't even parse bytes with Hyperlambda. There are no, I mean, it barely has types. There is no OOP, no classes, no polymorphism, none of that stuff. And actually, if you look at it syntactically, it kind of resembles YAML, yet another markup language, which is very frequently used among companies to create continuous integration and continuous deployment types of pipelines and things like that creates so-called DevOps environments. And Hyperlambda very closely resembles YAML, yet another markup language. Let me send a link to that too. YAML. So, but it is not YAML. It is a specific syntax which we actually had to create in order to be able to facilitate for having Magic doing the thing it basically does, which basically is automatically creating code. Now, if we do the math on this, so let me find my calculator. So it produced 3,457 lines of code, right? We know that the average software developer can produce between 325 and 750 lines of code per month. That's an average of 550 lines of code. In 1 second, ignoring all other factors, this system produced 6.2 months of work for me. So when I click the codifier here, and actually let me delete the folder just to illustrate this once more. Delete. So now I don't have the Sakila folder. If I now go to the codifier, I choose the Sakila database. I click codify all tables. 3,419 lines of code 1 second later. 3,419 divided by 550 being the average, 6.2 months of work for a single human being. So my bet upon the future is that the way we create software is going to significantly change, right? Now, historically, software development has been an immensely human resource intensive type of job. And I believe it still will be very, very human resource intensive. But I believe what we are doing is going to slightly shift in the future into becoming very much more different types of things than the things we have done for the last 50 years when we have created. Why? Because automation processes in regards to generating software and producing software automatically for us becomes better and better every single day. So I don't know how many here of those participating has ever tried Github Co-Pilot. So let me send that to your chat too. Github Co-Pilot. Github Co-Pilot is basically machine learning based AI system that GitHub created that allows you to create a comment. So you can go into a file, just create an empty file here, active folder, new file, okay, foo.md, for instance. So you can create code like this. This function retrieves the 10 last items from Stack Overflow related to, sorry, my spacebar isn't entirely good. C#. When you mark the code, you right click and you have a button in your IDE that basically goes into GitHub, goes through 200 trillion code snippets whatsoever, uses speech, text, not speech, but uses textual based pattern recognition AI algorithms to find what it considers to be the function that the most adequately actually implement what your comment says it should do. Now, if you go 10 years back in time, things such as these were science fiction, right? There was no mechanism within the human mind to even comprehend such ideas, like some of the stuff we are doing today. Now, purely mathematically, the magic scaffolder and its ability to automatically generate code, I mean, if you quantify it down and you ignore everything else, such as business logic and stuff like that, it produces code 234 billion times faster than a human being. So then obviously the question comes, okay, so what's left for us, right? Will this be like chess, right? I mean, Garry Kasparov lost to Deep Blue in 1996, and ever since that day, there hasn't been a single human being capable of actually beating a computer when it comes to playing chess. Well, chess is a game with perfect information, right? That means that if you can have a supercomputer with capable of perceiving more moves in chess than there are atoms in the solar system, you can actually create a computer that is 100% certain of winning every single time if it starts with white, regardless. It can play an infinite amount of games and it will always win if it starts with white, because white has a tiny advantage in regards to black, because it has the opening move, right? Now, software development is not a system of perfect information, right? Why? Because software systems lives in symbiosis with their environment, kind of like, you know, animals out there in the jungle. They live in symbiosis with each other and with the trees and the wind and the rain and the temperature and everything around them. A software system lives all in a similar type of symbiotic relationship with human beings, right? So it's not the system of perfect information. It is, even though it has a lot of things that could be applied like perfect information, such as the ability to codify a database, it's still not, in general terms, a system of perfect information. Because there's always the question, do you want to have a blue or a red button, right? Do you want to have a drop-down list or a checkbox? Do you want to have a radio button, right? You have all of these things where it interacts with us, where it is not a system of perfect information. So, and then of course, once you've used the codifier to generate a backend, you can also write HTTP endpoints using SQL. So I can go into here now and I can start typing my SQL. Select all from actor A where A dot first name like at filter. Then I add an argument here, name it filter, type string, type string, and I choose my HTTP verb get. I choose my primary URL, and I can choose a secondary URL. Let's call it India. And let's generate it. If I now go to analytics, find my endpoints, I find India. I invoke this for the filter being B%. B%. It's only going to return actors whose first name starts with a B. So this allows me to, in addition to actually automatically generating CRUD HTTP endpoints, wrapping my existing database, it also allows me to actually literally write HTTP endpoints using nothing but pure SQL structured query language for RDBMS databases. And then when we are done with the SQL parts, I can produce a front end, Sakila, choose template, Angular. Here I can provide my email address, my deployment domain, my API URL. I can choose colors, per pink, light or dark mode. I can choose which modules I want to include, which components. When I'm done, I click generate, and I get 30,000 lines of Angular code in a zip file downloaded to me automatically. And if I expand this, I look at source, then I look at app, then I look at components. I will see I have a Sakila folder here, and here's one folder for every single table in my system. If I look at one of these folders, you will see that it is basically just a plain Angular project using material tables and things like that. And in fact, let me illustrate that by opening it up in Visual Studio Code and have a look at the code, such that we can actually look at what type of code Magic uses. So if I now expand source, app, components, actor, and have a look at, for instance, this thing, you will see that this is perfectly assembled Angular code. There is nothing mysterious about it. This is the typical way you would create a data table in Angular using material. Here you can see it's TypeScript code, automatically produced according to which columns I have in my database, etc., etc. And instead of me compiling this project locally, because it actually takes 100 times longer time to compile than to create, which is kind of difficult to believe, but let me, instead of compiling it locally, actually show it, because we've deployed it online. Sakila.servergardens.com, and here is this particular Angular project. So all in all, we're talking about 3,500 lines of backend code plus 29,000 lines of front-end code, equal, divided by 550, 59 man-months. Divided by 12, 4.9 years. One human software developer, and the system produced it in 1 second. So a human being reproducing what I did now literally in 2 seconds would require 4.9 years. Now, yet again, there's no business logic to the backend. It's only CRUD. It does require authorization and authentication. And in fact, those wanting to play around with the system, let me send it to you in the chat. Here is the link to the system, and the username and password is admin. You can log in there immediately if you want to play around with it. And then if you look at some of these tables, such as film actor, yet again, here comes the metadata ID, because the system is automatically capable of actually recognizing foreign keys. So film_actor, of course, is a many-to-many link table between the database table called film and the database table called actor, which basically just contains 2 IDs, actor ID and film ID, allowing you to link UMA towards, for instance, analyze Hoosiers, right? And I now created that association. For other things, such as rental, having datetime pickers, it automatically recognizes the type and transforms it into a datetime picker. For other things, being referential integrity into stuff, it creates drop-down lists. For other things, being having more things, let's see if we can do some auto-completion here, etc. Return date, of course, is date, etc. Inventory ID, I don't know. This is probably going to fail. Ah, it worked. So at the end of the day, what you're looking at is basically a software development platform that arguably automatically does a lot of the boring job we used to do before. And in a way, you can compare this to unit testing, right? Because unit testing is the ability to create a snippet of code that tests your code such that you have the freedom to change that code and execute the unit test and verify that the changes you apply to the code does not break the code from an API point of view, resulting in that some other part of your code breaks as a consequence of you modifying the code. So, by the way, am I going too fast? Does anybody want to give me some feedback on if I'm progressing too fast or too slow, or are there other things? Thank you, Vadikari. Thank you. So, and thank you, Aman. Sorry if I don't do justice to pronouncing your name. So, okay, thank you, Paki. Then I'll continue at this same pace. I figure probably all of you are, software development students or computer scientist students or things like that. So, I mean, I can probably skip IDEs such as SQL. You probably at least have some idea about what it is already. So let's dive further into the code here and actually have a look at it, because this is kind of like the interesting point. Now, if you look at the get HTTP endpoint here, for instance, actor.get.hl, so you see the name of the file and its folder is actually semantic here. Here you can see that the file exists inside of a folder called modules. Inside of that folder is another folder called Sakila, and inside of that folder is a file called actor.get.hl. For those acquainted with the HTTP standard, you obviously know that there's like a handful of verbs you have in HTTP. You have get, post, put, and delete, and then sometimes some people will also use patch. These are like the primary HTTP endpoint verbs you have. And they're part of the HTTP standard, and get typically retrieves. Put is idempotent, implying it typically updates. Post is not idempotent, implying it typically creates. And delete, of course, typically deletes items. This happens to be basically just an acronym for CRUD, CRUD, create, read, update, and delete. So basically the HTTP standard intrinsically at its core is a CRUD standard, you might argue. Now, if I try to execute by holding down function on my Mac and clicking F5, make sure that this thing has focus when you do it. This opens up the invocation module form, allowing me to immediately invoke this endpoint. Here you can see verb, get, and then you can see the URL here. So there's obviously a relationship between the file's physical path on disk and the verb being get. Here, whoops. Sorry about that. Let me try again. The file name, the path, and the verb. Now, the initial part, magic, is basically a magic URL resolver that dynamically resolves the HTTP invocation towards a file physically existing on disk. If I rename this file from get.hl to post.hl, the verb will be post. And actually, if we open up this file, actor.post.hl, the only difference being it says post instead of get, you will see that now it has the post verb, actually. Now, and the system is entirely based upon metadata. Here I can India, this guy. Now, hopefully that worked. 201. If you now go to get, invoke it, actor first name like Sam. Actually, let's do first name equal, invoke, and here's Sam. Right. When you look at these arguments that the system automatically produces for you that allows you to do paging and filtering and ordering and such, they have like a semantic way of describing. And it's similar-ish to the way Python and other high-level programming languages typically use operators. EQ means equal. Like is a special SQL type of comparison operator that allows us to add a percentage, %. Basically means get me every single first name that starts with the character S, and then whatever, right? So it's basically a wildcard search. So the percentage basically becomes the equivalent of a wildcard here, for those not acquainted with SQL. Now, the structure of this file is important. As I showed how the physical file path resolves to an HTTP URL, then also typically each file starts out with an arguments collection. An arguments collection basically declares what type of arguments this particular endpoint can legally handle. Now, if I, for instance, let me just verify, let me just delete authorization. By the way, now I can invoke it in anonymous mode. If I now open it in incognito mode, it actually perfectly returns items. Why? Because I deleted this thing. I save it and do it again and open it in incognito mode, it's going to be access denied. So basically this line here, auth.ticket.verify, basically verifies the JWT token is valid, the user is authenticated, the token is not expired, and the user belongs to one of two roles, being root or admin. If I delete it and save it, F5 again, copy the location URL, I'm perfectly capable of retrieving items in incognito mode, not having the authorization JWT token passed into the get endpoint. Now, so the arguments here, these are the only legal arguments I can pass into this endpoint. And of course, this being a get endpoint, it doesn't take a payload, so every single argument has to be supplied as a URL query parameter. So if I now copy this and I do something like this, and then I add question mark, first name dot eq equal C %. This is going to work? No. Let me try again. First name EQ Sam. There you go. Now it's returning Sam to me, right? If I try to add an argument that doesn't exist, I write XXXX here. It is actually going to trigger an exception that automatically logs an entity into my database, allowing me to later actually retrieve it and see what was wrong. And here you can see explicitly it says that, okay, actor.firstname.eqxxxx is not a legal argument. Why? Because it's not up here. Right. So this allows me to kind of like think about an HTTP invocation the same way I think about a function signature in something such as JavaScript or Python or C# or something like that, where this becomes kind of like the signature of my HTTP endpoint. And of course, I can add as many as I want to. I can do foo, and then of course I can write manually if exists foo.lambda return result Easter egg. Save, and if I now invoke this, I pass in foo. Easter egg. Right. So as you can see here, I can clearly create if statements the same way I would, well, not the same way, it's actually very, very different, and it's very, very different for a reason. But I can still declare if statements, I can still declare while statements, I can still declare else and else if and etc. All of those things you are used to from a more traditional type of programming language. But everything is weird. Now, why is it weird? because Hyperlambda is actually twofolded. What you are looking at now when you are looking at the Hyperlambda is basically just a textual representation of a graph object or tree structure. And that tree structure happens to be what is commonly referred to as Turing complete. Turing complete is basically, to simplify things, the definition of what constitutes a programming language. So in theory, you could create anything with Hyperlambda, you can create in any other programming languages, because that is the definition of being Turing complete. Turing complete program can solve any problem that any other program in theory can solve. So, but with one crucial difference, being that because it is a graph object instead of a compiled binary, I can actually traverse this, right? I can traverse the code for my language semantically. And let me illustrate that by going into the tools here and showing the evaluator, because the evaluator allows me to instantly execute Hyperlambda. If I do 1, 1, 2, bar 2, 2, 3, bar 3, and then I do for each, adds, result, get the nodes, hash, and then I add a result node here, dot result, and then I execute it, and you will see all of a sudden now basically what it does, loops through every single child node of the node whose name is data, dot data, being this guy, and here is its child node. Then it adds, you can see the result here is empty, while down here it actually has 3 items. Then it adds the currently iterated node into the children collection of my dot result node here. Now, this is super weird for computer scientists and software developers, because Hyperlambda literally doesn't have variables, right? Because everything is a variable. If I want to do for each here, I can do a for each keyword inside of methods if I want to. I can iterate on programming constructs such as while. I can open up 1,000 files consecutively and find each file having an invocation to the slot called while, being the while keyword if you wish. Now, to illustrate the usefulness of this, let's have a look at some of the I hold down Option and click L, or Alt L on Windows it's the keyboard shortcut to this button. Then I can do, for instance, count look here. Look, of course, being lines of code. Here I can provide a folder. Let's do Sakila. Okay, then I unwrap all expressions inside of this particular node, being of course this one. Then I have an integer here, starting out with the value of null. For each result of this signal invocation, it splits the strings on basically caret return, ASCII 13. Then it increments the .nu value up here by the number of nodes this string splits invocation results in. Basically, it counts lines of code. That's what it does. Whoops. And here we go. In the Sakila folder now, at this particular point in time, there are 4,213 lines of code, or caret returns, if you wish. Now, if I want to, I could easily expand upon this one, and I could, instead of doing the string splits here, I could do lambda hash. and that one didn't quite entirely work. So let me figure out why. Hyper to lambda at TP. The point is, I couldn't quite figure out the exact syntax at this particular moment, but the point is that I can actually query my code base almost the same way as you would query your database. So to write this in pseudo code, select file names from all files in module Sakila where invokes data.read. Now, of course, this is pseudo code, but it basically becomes the equivalent of giving me the ability to query my code base the same way I would query my data. So Hyperlambda basically eliminates the conceptual difference between code and data. And then it turns code into data, at which point all of a sudden we can actually start creating processes, automated processes that actually modifies and patches my code intelligently. And when I hired my current head of backend development, when I showed him this and he started thinking, and I could just see it in his eyes. Oh my God, when we add AI to this. And of course, once you have the ability to actually add AI, and of course that's a next step for us. I mean, obviously we're going to add AI to this, right? Then you're basically ending up having code that self-evolves with its meeting with its environment, such that we, of course, being its environment, the same way, you know, animals are self-evolving in the rainforest of Amazonas. They are evolving because, you know, some animals are being eaten by birds, and therefore only the fastest ones survive, so that everybody starts running faster. And then all of a sudden you get these really, really rapid mouses or rats or whatever. You have, you know, butterflies that can fly like as if they were eagles in the rainforest, etc., etc. And this is because they meet their environment, and then this triggers changes within them, ensuring the survival of the fittest. And you basically get the same capacity in your code once we start adding artificial intelligence into this, where actually the AI is capable of automatically modifying the code according to our needs and our wants, and our being its environment, of course, us being its environment, and our personal needs in regards to the code. So, and then, of course, you have all of these other tools. You have management here. So the system started basically out as me being tired of repeating myself in code. I started coding when I was 8 years old, and I started professionally when I was 22. So I have like 25 years of professional experience as a software developer and 39 years of experience as a non-professional software developer. And over time, of course, I realized I was repeating myself over and over and over in code. Right, I've been working for dozens of software development companies, and every single software development companies I've been to, they've been asking me to implement user and roles administration. Okay, so some of the idea behind Magic is that we provide that out of the box. foo@bar.com, foo, and I'm now created user. Now I can associate that user to the root role. Now this user is root. If I now impersonate the user, this gives me a link on my clipboard containing the JWT token, automatically authenticating me towards this particular backend as foo@bar.com. And of course, now you see I'm logged in as foo@bar.com. So all of these recurring tasks I saw in my day job, that I needed to do over and over again every single time I switched employer. I just told myself, you know what, I'm going to stop doing it. I'm just going to solve it once, forever, permanently, and that's the end of it, really. And then we have things such as terminal. Etc. It's not perfect. It's not like you can't, you know, do feedback for passwords. If I do sudo and it asks me for a password, then it fails. So, but it's good enough for my particular purposes. And then, of course, in regard to the business logic requirements, that's the first thing an experienced senior software developer always asks me about. Is what about business logic? Well, actually, we do have business logic here because we want to, by the way, write down this code. Free your mind. Let me send it to you in the chat. If you go into the bazaar and you type this as your promo code, you bypass PayPal and you don't have to pay for anything. So you get all of these for free. So, and what is this? Well, it's basically just a zip file containing Hyperlambda code, and that's it. This is plain Hyperlambda code. If you now open up Friday, we can expand modules. We can look at Babel, and here's the code we just installed. And these, of course, are small snippets of microservices created in Hyperlambda, solving some particular need required to having business logic, if you wish, inside of your app. If you delete this guy, active folder, delete. Let's delete Babel mail 2 at the same time, delete, and Babel fish. If we now go to the bazaar and we have a look at what they actually do, you will see here the README file basically explains it fairly accurately. So Babelfish, this is like a microservice translation type of backend microservice that allows you to translate entities such as text values for buttons or checkboxes, etc., etc. And of course, all of these things are recurring, repetitive problems. We have seen in our day jobs working for traditional software development companies previously. So, by the way, this code, Free Your Mind, gives you all microservices for free. So I'm obviously not here to charge students. So, what more do we have here? Yes, so we have the log that allows me to easily, you know, and I can, from my own Hyperlambda code, if I go into the evaluator. Now, the evaluator is your primary weapon of choice when you want to teach yourself Hyperlambda. You can find it under Tools, Evaluator. And then you can load snippets here. And all of these snippets demonstrate some aspect of Hyperlambda. For instance, let me see if I have a weight. No, I don't, but I have a fork here. This, for instance, demonstrates how to create multiple threads in Hyperlambda. And as you can see here, it sleeps for 100 milliseconds, then it logs inside, and then it logs outside. So what do you think the result of this is going to be if I open up my log after having executed it? Try to think a little bit about it. It's actually kind of a puzzle. It's obviously going to log outside first, even though technically it's, oops. Well, I was wrong. It logs inside first for some reasons. So, but anyway, the evaluator is your primary weapon of choice when you want to teach yourself Hyperlambda. Here you can see how to invoke an HTTP GET invocation from Hyperlambda. If I add now, of course, it returns it as bytes. If I add convert here, it automatically converts the thing to lambda. And the structure of Hyperlambda, to say a little bit about that. So here you can see this slot invocation to HTTP GET has 1, 2, 3 spaces. Okay. This headers node here is a child node of HTTP GET. And 1, 2, 3. Okay, so this node here is a child node of headers. Then you can see all of these are basically children to headers. Why? Because there are 3 additional spaces, indenting it 3 additional spaces from its parent node. So it's similar to Python in those regards, that it uses spaces as semantics. If you now go down headers, we find content is de-indented, 3 spaces. So it's only 3 spaces below HTTP GET. So HTTP GET has 2 children nodes, headers, and content. And content here, of course, have these 3 children nodes, etc. So it's all about 3 spaces, either in or back again, declaring basically at the end of the day a node structure. And the node structure, if I was to write it with pseudo code, it would look like this. String name, object value, list node children. And this is basically pseudocode that basically more or less correctly describes the actual underlying structure of what Hyperlambda ends up becoming after it is parsed. So this is going to sound fairly weird, but actually, and I think I can show it at our website. I think there is a link about it here somewhere. Let's see, Hyper ID, if I can remember where it was. When I can send you these articles. In 2017, I wrote my first article for Microsoft about active events, which is the design pattern. I'm going to send it to you in the chat here. That actually facilitates for Hyperlambda. And they actually had to add a disclaimer here because they thought I was crazy, literally. Because here I have this programming language, it's not compiled, it's not interpreted. And people are like, what? You can't create a programming language that are neither interpreted nor compiled. It's not even possible in theory. Sorry, I just did. So they were a little bit afraid because none of them could really understand what I had done with this Hyperlambda. And I wanted to write a series of articles. So this is one. There's another one. Explaining what I had done from like a scientific point of view. And so they actually felt they had to have a disclaimer that basically said, we think there's a 90% probability of that this is just not simply not true. This doesn't make any sense. It has statements that makes every single developer we show it to become outraged. It sounds like fairy tales, but it wasn't. And here's the proof, really. So, and the task scheduler here, let me demonstrate it too. Allows me to declare repetitive tasks. hello university. Save, can schedule it to run repeatedly, 5 seconds, 3 seconds. Now if I go to my log, then every 3 seconds I will see a new log entry being created saying hello university. And then it repeats over and over again. And of course I can schedule tasks for running at a specific date and time. Tomorrow, 16:43 if I want to. I can delete schedules as I wish. And of course, the point being that this is a fully fledged Hyperlambda execution environment, giving me the entirety of the programming language. By the way, the autocomplete on Windows, hold down Control and click space. Just make sure you have focus inside of one of your Hyperlambda code mirror editors. On the Mac, it's function control and space. And I can, of course, do io.file, function control, space. And I get only slots that starts out with whatever I have written so far on that particular line of code. So, are there questions? Maybe we should take a little bit of a question round now. I'm not sure. Are there any questions? Shambhavi or Sam or Samart or Aman?
No, so we don't have any such questions till now, but anyone can ask. If they want to ask any question, they can put it in the chat Q&A section. It's open now.
Yeah. Then in the meantime, while people are pondering questions, let me show one really, really cool feature, which is my personal favorite. But most people I show it to tend to be like, And I think it is a matter of mental vocabulary. Because you see, the human mind is created in such a way that it, if you go 10,000 years back in time and you were flying a balloon, a hot air balloon, and you were flying it over a village, then people wouldn't see it, literally, because they lack the cognitive vocabulary to imagine such things. And we have seen this time over and over again, such as when Columbus came to America. The natives, these boats they were traveling were so large that they couldn't imagine that there were human beings inside of them because they had never seen such large boats before. Now, this is a general problem in the human mind more than in regards to computing or creativity, which is that when you're shown something that you've never seen before and that doesn't resemble anything you've ever seen before, then it becomes difficult to believe in. Now, let me show you this one particular feature inside of the evaluator. I click the load button, I filter on crypto, I choose magic.crypto.hp.eval.idempotent, and yet again all of these snippets are inside of the default download of Magic. So anybody having downloaded Magic locally will have these immediately. So let's have a look at what this snippet does. Okay, so first it obviously creates a new GUID, 128-bit randomly generated thing. For those not acquainted with GUIDs, Global Unique Identifier, that's what it stands for. Then it unwraps this variable down here, basically, which just references again the value of this GUID. So basically this becomes a randomly generated GUID, Globally Unique Identifier. Then it has a lambda object here, .lambda. Okay, so this is obviously Hyperlambda. It's like a dynamically created function, if you wish, that basically declares some piece of Hyperlambda. Then it provides a URL argument to a signal, which again invokes a dynamically created slot called magic.crypto.hp.eval, passing in this URL as the invocation endpoint and this lambda object. So let's execute this code now. And as you can see, it immediately executed and returned success. There's no HTTP error here. Now, what actually happens here is that if we go into management here and we have a look at the cryptography menu item here now, and we have a look at the receipts here now, you will see that 19 seconds ago, this code here was passed into this server. I'm of course just doing loopback here because I'm doing it from localhost to localhost. But I could do it from one server to another server, being in 2 different countries on the planet if I wanted to. Then it has a signed request here, and obviously we're in the cryptography menu item here, so obviously there is some cryptography occurring here. Actually, what is occurring is that it takes this Lambda object here, which is basically the DOM, document object model equivalent of Hyperlambda, then it transforms it into text, being its Hyperlambda equivalent, then it cryptographically signs that particular text with my server's private key. Here is the public key, but there is a private key too associated with this public key. Then it transforms that cryptographically signed array of bytes to this endpoint. This endpoint again verifies that the payload is cryptographically signed. Then it retrieves the fingerprints for the public the key that it has stored here, being this guy. And then it checks this list of vocabulary, being legally allowed slots to invoke for the owner of this particular public key. Now, at the end of the day, what this basically implies is that if I do io.files.delete, basically this deletes a file, right? Then it fails. Invocation to cryptographically signed, secured HTTP endpoint return, failure. Why? If you go to our log and have a look at it. Slot io.file.delete doesn't exist in current scope. So basically the server can declare a bunch of slots or functions that the owner of the private key belonging to this public key equivalent, RSA, by the way, for those versed in cryptography, being a legally allowed vocabulary that the owner of this private key is legally allowed to invoke on my server. This allows me to actually create an endpoint where I can have clients provide code to my server that my server then executes. And then the client decides not only what it wants to have returned from my endpoint, but also what code it wants to execute on my server. And more importantly, this construct allows me to do so securely. Because if I provide a malicious slot here, such as I did with the io.file.delete invocation here, then I get, invocation to cryptographically secured HTTP endpoint returned. Sorry, you're not allowed to do that. So it completely turns, you see, typically when you have a function or an HTTP endpoint, that endpoint takes data. And then the code inside, behind the endpoint, executes using your data as inputs and then returns the result of that execution back to you. Now, with cryptographically signed Lambda invocation, the responsibilities are completely reversed, such that the client actually provides the code and the server provides the data. So it allows you to actually securely, from a client, send code from that client to a server, assuming the server has given you execution rights somehow to execute some specific slots on itself, for then to return the result back to you. Now, semantically, you might philosophize about this, that it becomes two computers' abilities to logically communicate. When I'm communicating with other human being, I'm basically transferring logic. So I have an ID in my head, right? The ID can be coffee, right? Then I transform that ID from my head using language as my preferred mechanism to the receiver of that message we happen to be sharing a language such as Indian or, you know, English or Norwegian or Greek or something that allows the recipient of that particular, you know, sentence to decompile what I was saying and turn it into a visualization of coffee, one way or another, such that we are able to actually logically transmit or transmit logic from one mind to another mind. This is that thing, except it's for computers. So, but everybody whom I explain this to, they're like, so, because they lack the you know, the ability to creatively imagine what such constructs could possibly be used for. But it is basically the equivalent of human language, except it's not from human to human. It's actually from Hyperlambda execution model to another Hyperlambda execution model. So it's arguably more inspired by actually nature than software and computer science, which is probably going to sound weird for people, but that is a good advice, by the way, too. If you want to be truly innovative in IT, then stop thinking about IT and start thinking about music or nature or Charles Darwin or physics or something. So, were there questions?
Yes, we have a question. We have a question from Siddhesh Darak. So he asks, can an entire large-scale application project be made just by the use of Hyperlambda?
Yes and no. You see, there are a lot of things you cannot do in Hyperlambda. The advantage about Hyperlambda is that it is very, very easily extendable. And actually, let me demonstrate that by opening up Visual Studio Code here. Let's just open up my backend. Then let's find slots here, and let's copy this guy. Call it foo, or add to numbers. Now I'm creating a new C# class, literally. Add to numbers. Move the comments for clarity. Then input result value equal input children first. Children skip 1. Let's recompile this particular backend. So I've now created an additional C# class that exists in my currently executing backend. Right, and this class, its name is add to numbers. I have one simple attribute here for this particular class, whose name is slot. Slot again has a property called name. I give it the value of add to numbers. Then it implements an interface. The interface is called iSlot. That interface has one single method called signal. Signal takes an iSignaler here, and it takes a node. And by the way, here is the node class I showed you previously as pseudocode, having a name and a value and children nodes. This is basically the .NET C# equivalent of this is basically the C# equivalent of Hyperlambda. So when Hyperlambda is actually being parsed into that graph object, that tree structure I spoke about earlier, what is actually the result is a node. And a node, of course, has a name, it has a value, being an object. and it has children. So now, if I go to my evaluator here and I refresh, and I hold down function control space or control space on Windows, add two numbers. Five, 7, execute, and of course, no surprise, 5 plus 7 equals 12. So it provides an extremely easy mechanism for me to actually tie into .NET and C# or F# or any .NET language I wish. So actually the backend is entirely written in .NET in C#, written like this. And even the while thing is actually just a slot. For each is just a slot. Everything is a slot in Hyperlambda and Magic. So here you can see add two numbers. Okay, here you can see add two numbers. So basically this, the value of the name here on the slot attribute basically becomes its Hyperlambda keyword, if you wish. So whenever you're stuck with Hyperlambda, when there's something you can't do with Hyperlambda, it's literally 17 lines of code to enter C# and pass arguments from your Hyperlambda into C# one way or another, and do whatever you need to do in C#. This is why it's almost as fast as C# and .NET, because all of these slots are extremely high-level constructs that typically has a lot of I/O, network reading, things like that, databases, etc. So the overhead of Hyperlambda isn't in Hyperlambda. It's always waiting for I/O data or waiting for the network adapter, etc., etc. And that's typically where you do have the overhead when you come out to an employer and they ask you to create an app, CRM system, maybe to track whatever they want to track. Then 99.9% of the time your software is executing, it is waiting for data, either from the database or from the file system or from an HTTP GET invocation, or etc., etc. So unless you are doing extremely heavy algorithmic type of software development, then the additional overhead that Hyperlambda carries on top of C# is negligible. You don't really need to think about it. So the answer to the question is no, but yes, because you can always enter C#. So you can create extremely super complex applications. I mean, if I wanted to, I could create a signal here called, machine learning, right? And then I have some, neural network, deep learning, whatever, taking arguments and, providing some sort of AI result back to the caller as Hyperlambda. So did that answer the question?
Yes, certainly.
So of course we are focusing a lot on the automation capacity, right? If I now go to Credifier here, I choose any database. Let me just verify that I don't have a. Guess let me delete these modules. If I go to the Credifier here, then regardless of what database I choose, and I can choose MySQL, SQL Server, PostgreSQL, or SQLite, then whatever database I choose, it basically automatically wraps that particular database. 665 lines of code, Babelfish, it's a smaller database, 300. Sakila is a little bit larger. Of course, what we're focusing on a lot is the automation parts. But it actually is a Turing complete software development platform, right? It is a fully fledged programming language. And it's also a DSL, implying domain-specific language engine or templates for creating domain-specific programming languages, which you basically, to some extent, saw here by me adding this slot, add two numbers, right? So, but our focus, of course, is because, I mean, we are a company, right? And, you know, even though I love to do these things, I love the fact of that everything is open source. I love the fact of that students can download it and play with it and have fun. I love the fact of that, you know, individuals can download it and, you know, maybe create some sort of like business model based upon its existing open source version without even telling me about it. I mean, the philanthropic point of the system is why I wake up in the morning. But it's not why I can wake up in the morning, right? I mean, at the end of the day, we are a business and, you know, we have, you know, business requirements, you know, we need to make money to pay salary and et cetera, et cetera. So what we will be focusing a lot on is this part, the automation, SQL, front ends, and because this is the thing that sells, right? But if you're smart as students and you want to learn Magic, you go in here and you go through one snippet at a time and you understand them. When you're done with that, you do cache sets. When you're done with cache set, you go to count look. When you're done with count look, you go down to for each, etc., etc. And you try to understand the programming language because that is really the goal of the thing. And let me send you the link to where you can get started. This is where you start. Let me send this in the chat. So you start out here, you read through this. This first article helps you to set up Magic locally. The next article walks you through the automatic codification process of your database. The next article after that, you just go through them one at a time. Shows you how to create a web API using SQL, and there are videos embedded on most of these articles. Next article shows you Hyperlambda Hello World, how to return, you know, custom things, and this is where you start coding in Hyperlambda, you might say. And then it goes through invoking HTTP endpoints, etc., etc., sending emails. So, yeah. So, are there any more questions?
No, there aren't. We don't have any more questions.
Okie doke. So we have some minutes left if you want me to show you something specific. Let me see what we haven't gone through. Assumptions. These are kind of funny. So what is an assumption? Well, an assumption is kind of like a very, very high level unit test or automatically generated assumption. Let's say, for instance, if my wife gives me a cup of coffee, I assume it will be full of coffee, right? And that I can drink some coffee, right? So that's an assumption. If it isn't, there's something wrong somewhere. Now, when I create these endpoints using the codifier here, and I created, for instance, the Sakila database here, right? And I overwrite and I codify all tables. When it's done automatically generating the code, I can go to my endpoints. I can filter on Sakila. I can find, for instance, actor delete endpoint, right? Then I can invoke it without passing in actor ID. And of course, this is going to trigger an error. Mandatory argument, actor ID, not given. field actor ID. This allows me to semantically from my front end actually show the actual specific text input, whatever, that triggered, this particular error. And of course, it's a 400 bad HTTP request. So it's an error. The server says, sorry, man, I can't handle your payload. Your payload is bad. I need actor ID. Now, the cool part here is that I can now create a new assumption saying Sakila.actor ID.delete not working fails no ID. Assumes that you cannot invoke the delete actor without an explicit ID for which actor you want to delete. Now, the reasons why this is cool is because if I allowed invoking this endpoint without an ID, then it would actually not delete one actor, but it would delete every single actor in my database, which would be a problem, of course. And if I now go to my assumptions, here's the assumption. And it was basically automatically generated. I didn't write a single line of code, right, to achieve this. Still, I now have one additional unit test. So the system also automatically creates unit tests, although unit test isn't the correct word. There doesn't really exist a very good word for it. I guess the best one is integration tests, because a unit test is never supposed to touch the database or networking or anything like that. So these aren't unit tests technically. Now, of course, when you have a large system with 5,000 HTTP endpoints, there's no way you can quality assure every single endpoint for every single release you have, right? So that's why you want to have an automation on as many of these aspects as possible. Well, now you do, right? So you can take your endpoints as you are generating them and automatically generate unit tests or assumptions or integration tests about them. That sanity checks your system before you deploy it into production. So this is a nice place to start. When you have downloaded Magic, you go to About Magic, you click this thing. I think there are 13 videos here that walks you through most of the system and teaches you. They're created by me. And this is also a useful link to tutorials, where you can find specific tutorials about Magic. This is the reference documentation. When you have gone through all the tutorials, this is the reference documentation for every single part of Magic and Hyperlambda. I think there's in total like 200-300 pages if you print out everything into a PDF. By the way, I would appreciate if you would give me a star here on my GitHub. That would be awesome. So for those of you with GitHub accounts, if you come here and give us a star, I would appreciate it. So, and here's the project's GitHub page. The place where we plan upon, obviously everything is a little bit new. We just had a company 1st of December actually, and we still don't have our onboarding product even ready yet, but this is where we'd like to keep discussions and questions and things like that about the system. If you find issues, if you find bugs or have feature requests, okay, then you can go here and ask specifics about that. And then, of course, our website is here. If you want to download it, the easiest way is actually to go through here and either Docker Compose or source code. This ensures you always get the latest version. Vista.com. So thank you, by the way. I saw some of you already had given me stars.
So could you just put some light on what the student need to do to get internship?
Yes, internship. Now, obviously, we're a small company. There's only a handful of employees. So we have to, and we're also in the middle of a release, a big release. We have 15th of June. 2022 now in only 2 months from now, But if you want to have an internship, obviously, the more passionate you are about Hyperlambda, the better it is for us, right? So my suggestion was actually to have a competition or something. I'm not sure how many would want to participate, but the idea I was thinking about was to actually create something open source that is beneficial for your community, whatever that happens to be. If your parents are working at the library, maybe it would be, I don't know, book registration system, whatever, some itch you happen to have yourselves that you want to scratch. Because my experience is that if you want to create great software, you have to love the software, and to love the software you have to need the software. If my idea about an internship is actually that the internship was to last some 2 months. I would follow up on the person personally, like 3-4 hours a week, 2 sessions, maybe Tuesday and Thursday or something. And then in between, the student would work mostly on his own to create an open source thing, right? And then, of course, this would provide us with like an open source example project built using Hyperlambda. This would give the student the opportunity to learn Hyperlambda and learn the platform in general. And then, of course, we'd provide a good reference to whomever wants the internship at the end of everything, and we'd market this open source thing. So because some of our our backend code, right, it's like you need 15 years of experience to be able to dive into this part, right, for the stuff we are publishing out as our end product. Of course, I want to teach those things to students being interested in it, but that is the process I have kind of like thought about myself. Does that sound like a good process, or I'm open for suggestions here if it sounds
That sounds great, sir. Sir, I just want to ask, can we the students participate in group, like they can create open source project in a group, or they need to participate individually only? And secondly, do they need,
if you want to, yeah, sorry.
and secondly, do they need, how can they share their project, like via GitHub link or some other process?
Well, if it's open source, then from our point of view, the reasons why I can justify this, right, spending 3-4 hours a week in the middle of a release, is because it gives us a sample use case, right? All of our existing partners, they're writing closed source stuff, right? So obviously I can't showcase that. So from my point of view, the justification for this is that it's something open source that I can like show the world. It's cool. It's got some complexity beyond a certain threshold at the very least, and it also benefits the world, preferably your local community, whatever type of problem that community happens to have. And then that would justify me spending 3-4 hours a week following up on things and guiding and tutoring and things like that. So how you wish to share it is really up to you. But if the system is really amazingly great, if you just like create the best thing since sliced bread, then I'm willing to put it here, right? Somewhere, maybe not on the front page, but maybe here, have a use case here or something. So on a secondary link here, something such as this, where we showcase the system, and I maybe even demonstrate it with YouTube videos, and I brag about it, and I allow people to download it, and of course where I brag about the student or students participating in this. If you want to participate as a group, that would be awesome. That would be up to you. Of course, I do have, I mean, I cannot spend more than maybe 4 hours a week, 2 hours on Tuesday and 2 on up and tutoring and teaching. I happen to be best in regards to front end. I'm best with Angular, something Sam can verify, I presume. So if you want me to help you out with the front end, it's going to have to be Angular. If you're like super skilled in front end React and you don't need help with the front end at all, then go for whatever you wish, Swift or React or Flutter, doesn't really matter. So, but obviously the backend would have to be Hyperlambda. That's kind of like the point here. So, did I answer your question?
Yes, sir, you did right, sir. Also, we
Thank
have
you.
another one question from Monica Upaluru. She's asking, so based on the project, will we be selected for the interning?
Well, I mean, my idea was because I can only accept. The idea was to accept one internship. But if you are 2-3 people who wants to do the same thing, the same project, and collaborate instead, I could obviously take you on as a group, because I mean there is little difference between, you know, having 3 people in a meeting twice a week or having 1 person in that same meeting twice a week. That's a little bit up to you how you would want to do things. But the idea was that, you know, we had a competition where each of you created your own system, and then after a month or something, I evaluate the system and find a winner. Of course, I mean, if you know there are only 2 participating and both are just amazing, I mean, obviously at some point my heart would melt and I would have to accept you both. But it's a little bit up to you how you want to do this. If you want to do participate as a group, then awesome. I suspect that would be more better, right? Because first of all, it would allow me to have multiple internships without really having to spend more time than I would with one person. So, well, either only a single person or a single project, Monica. And the reasons why is because realize we're only 3 employees in Aista. It's me, the CEO, and I'm already working 80 hours a week. So I basically have to sacrifice something, right? I mean, I have to. There is one thing I have to throw out now to take on internships. And then we have the backend dev. He went to bed 11:30 last night. He woke up at 6:30 and started working again nonstop. And until 15th of June, everything is a zoo for us. We're all pushing 80 hours a week, all 3 of us doing everything, because we have this major release happening the 15th of June, where we're going to have the onboarding system ready. So either a single person or a single group. Right. Does that make sense?
Yes, sir. Yeah, it completely answers the question, right?
Yeah. If there's 3 of you and all 3 want internships, if you can figure out something to do together, awesome. I'll follow up on all of you, right? Because it doesn't take more time from my point of view to follow up on 3 of you than it takes to follow up on 1 of you, right? As long as you're working on the same project. Actually, that question, Monica, can we know what kind of project you're looking forward for? Actually, I am looking for something you need or your community, right? I don't want this project to be, this internship to be about something I need. I want it to be something that, you know, maybe your cousin is a farmer. Maybe he needs an irrigation, watering, measure, log. I don't know, right? I'm just throwing things at her. Maybe, you collect DVD films. Maybe you want to have a system to categorize your DVD films. So, yeah. It needs to be database driven. Obviously, it needs to. There needs to be some sort of like relational database backing it, either MySQL, PostgreSQL, or whatever. Yeah. So, did I answer your question? Monica, that's a Norwegian name, by the way. So we spell it the exact same way. So, anyways, maybe we should wrap up, or what do you guys think? Shambhavi, Sam, Samart, Aman.
Yes, we can wrap up. Thank you, sir, for such an amazing session. It was really nice.
Thank you.
To learn so much from.
I would love to later dive much deeper into the Hyperlambda mechanics. But I mean, obviously, I can't do that in 2 hours, right? So, I mean, a full course on Hyperlambda is like 2-3 days. After 15th of June, I would love to do that. So, if you want to have like a full deep dive for 3 full days into Hyperlambda, I'd love to.
Yeah, so that sounds great. We would definitely look forward to it. And about that internship thing, we will let you know how many groups or how many people are interested, and we'll give you the follow-up on that. Means how many are trying to do the projects, and we'll let you know the follow-up on that.
Awesome. So, okie doke. So thank you very much. It was nice, almost 2 hours. So have a nice evening, everybody. Thank you for showing up. Bye-bye.
Thank you, sir. Thank you.
Bye. Thank you.
Thank you.
Bye. Okay, so guys, I guess we can wrap up the event now.